Okay, here's another quadratic question. So we're going to show that x squared minus 8x plus 18 is greater than 0 for all values of x. So if it's greater than 0 for all values of x and the x squared is positive, that means there can't be any solutions. So a good way to do this is if we complete the square and work out what the minimum point is. We could also look at the discriminant, but later on we have a graphing question. So it's going to be really helpful to basically work out what that minimum point is. So we've got y equals, y equals x squared minus 8x plus 18. Okay, so if we're going to complete the square, we take half of b. So that means I'm going to do x minus 4 squared. So when I expand that bracket, I'll get my x squared, that's good. I'll get my minus 8x, that's good. But I'm going to get plus 16. So I have to remember to subtract 16. And then I've got the 18 that I had at the beginning. So once I put those all together, that means I've got x minus 4 squared plus 2. So my minimum point is going to be 4. It's going to be 4, 2. Okay, so that's going to be my minimum point, 4, 2. So that's my first one taken care of. Second one. Oh, sorry, yeah, one more thing. Basically, remember that it's show that, so don't skip any of these steps. Okay, make it clear what you're doing. The marks, there's 3 marks, and those 3 marks are for the method. Right, let's go to B. Okay, so now, if that function and g of x is 2x plus 5, sketch the 2 graphs. Okay, so now, let's do f of x first. So we know it goes through 4, 2, because we just found the minimum point. When x is 0, the y-intercept must be 18, because that's the only thing that's left. So I draw that curve, so that looks like a quadratic. Sorry, a bit wobbly with my pen. That's my quadratic. Okay, now I've got 2x plus 5, that's a linear graph. So I know that when x is 0, that's 5, so my y-intercept for that one's going to be down here. Where's it going to cross the x-axis? Where 2x plus 5 equals 0, so that's where 2x equals minus 5, where x equals minus 5 over 2. So that's going to be minus 2.5. Then I'll put my linear graph in. Yeah, right. That's my linear graph. Now I've got to put any points of intersection. I've got my x-intercept, I've got my y-intercept, I've got this y-intercept, and I've got my minimum point here, which is my turning point. So I've done B. Right, now C, points of intersection. So remember, points of intersection means where the 2 things cross. And now, if they cross, that means that f of x must be equal to g of x. So that means that my x squared minus 8x plus 18 has to be equal to 2x plus 5. Again, let's turn it into one single thing to find our solutions. Get together the like terms. So I've got x squared, I've got minus 8x. I'm going to take away 2x from both sides. Minus, I've got 18 on this side, I've got to take away 5 from both sides. So that's going to be 13 equals 0. So I want the solutions to this quadratic. And I find that x equals 5 plus or minus 2 times the square root of 3. And that's my intersections. Okay, so that's my 2 points here and here. Okay, Right, now the last one, D. Write down the values from which f of x is greater than g of x. Now, f of x, g of x, what we've done is we've made this into a quadratic. So if you think if f of x is greater than g of x, that means that f of x minus g of x has to be greater than 0. Okay, so and what have we done? We took away 2x to get this, and we took away 5 to get this. So f of x minus g of x is actually that quadratic we just found the solutions for. And then we go back to the same thing. If I've got a quadratic, okay, and I want it greater than 0, this is now 0. So where's greater than 0? It's greater than 0 in the tails. Okay, so x is not sandwiched. That means that our x for D is x is less than our 5 minus 2 root 3, and also, or x is greater than 5 plus 2 square root 3. So remember, it's not sandwiched between, it's the tails, so it's two separate inequalities.